Hello, Secondary 1 students, and welcome to the first day of online school. You guys are very excited, I'm sure. Yay! All right, so today we're going to be talking about parallel perpendicular lines. Surprise, surprise, right? That's what we've been doing for the last week. But we're going to be talking about the equations and basically identifying whether or not the equations are parallel, perpendicular, or if they're just going to intersect. Okay? So remember on the Friday before all the craziness happened, we were doing equations, right? We were writing equations that were parallel, and we wrote equations that were perpendicular. So just a reminder, parallel equations. So parallel equations have the same slope, right? And when I say slope, remember y equals mx plus b, right? The number multiplying with the x is your slope. The number that's adding or subtracting is your y-intercept. So basically, to identify if things are parallel or perpendicular, we're going to pay really close attention to that number that is multiplying with the x, right? So if they're parallel, those numbers that are multiplying with the x would be the exact same. Okay? Now, just a quick reminder, it needs to be in this form before you can see the slope. You will notice some of these problems are not in the slope-intercept form. So we're going to have to get the y by itself before we can compare and identify if these are the same slope or if they're different. Now, perpendicular lines, the slope is the opposite reciprocal. Now, what that means is if you have a fraction, so let's say 4 over 5, the opposite reciprocal would flip the fraction and change the sign. So it'd be 5 over 4, negative 5 over 4. Sorry, should say. So the fraction flips and changes signs when it is perpendicular. If it flips and does not change signs, that is not perpendicular. That would just be intersecting. Really, anything else, if they're not the same slope and the fraction does not flip or change signs, it is just going to be an intersecting line. Okay? So what we are trying to identify today is whether or not these lines are parallel, perpendicular, or intersecting. So again, we basically need to look at the slope of each line. If they're the same, they're parallel, and if they're perpendicular, the fraction would flip and change signs. Now, the key thing here that we need to go over is solving for a given variable. So you'll notice this is already in slope-intercept form. This would be my slope right here, 9 over 4. Okay? To get it in, or this other one is not in slope-intercept form. So the steps here are pretty basic. The first step, so the first thing we're going to do is we are going to try to get the y by itself. So we would move any term that is adding or subtracting. Okay, that's our first step. So if we look at here, here's my y term right there. This 4x is adding to it, right? So our first step is to move that 4x. So since it is positive, I would subtract. So if I ever want to move an entire term, it's just a question of adding or subtracting. We would only divide if we're trying to separate that from the variable. But if we want to move the entire term, we would subtract it to each side. That would give me 9y is equal to, and I'm going to move this 4x, negative 4x in front, so negative 4x minus 9. It doesn't really matter, but that just helps keep it in the form that you guys are familiar with. And then the next step is to divide any number multiplying with y. Okay? So next step is to divide any number that is multiplying with y. Here, 9 is multiplying with y, right? So we're going to divide, and again, when we divide, we have to divide every term. So every term gets divided by 9. Okay? So cancels out there. I'm left with y equals, I'm going to keep this fraction here because that's going to be what I'm looking for. Okay, and this becomes -1. So now the y is by itself. That means it is in slope-intercept form. The last step, the third step, is to compare slopes. So really getting it in the slope-intercept form should really only take 2 steps. Move any term that's adding or subtracting to the y term, and then divide by any number that's multiplying with the y term. And then the last step is to compare the slopes. So my original slope is 9 over 4. This new slope is -4 over 9. Is that the same slope? Nope, so it's not parallel. Is it the opposite reciprocal? The fraction flipped and changed signs, right? So the answer here would be perpendicular. These are perpendicular lines. Okay? Not too bad, right? Let's do one more. So let's look at number 8. So looking at this one. Again, this is already in the slope-intercept form, right? 6 over 5x minus 3. So we need to get the y by itself on this one so I can compare and see what the slope would be. So I start off by subtracting or moving the first term that is adding or subtracting, right? So I want to move the 5x to the other side. So it's positive, so I would subtract. If it was negative, I would add it. But since it is positive, I'm going to subtract it to each side. That gives me 6y is equal to, and again, I'm just going to move it in front, -5x plus 12. Okay? Then the next step is to divide any number multiplying with y. So this 6 is multiplying with y, right? So I need to divide it. And when I divide, I have to divide every term by that number. Cancels out here. I'm left with y equals -5 over 6x plus 2. Now the y is by itself. I can then do the third step, which is compare slopes. So my original slope is 6 over 5. My new slope is -5 over 6. It is not the same slope, but they do flip and change signs, so this is also perpendicular. Okay, and that's it. That's all you're doing. Again, if it is not the same slope, or if the fraction does not flip and change signs, like this one does not flip and change signs, it would just be intersecting. And that is it. Happy first day of online school.